Hey there, space explorers. Do you remember that epic movie Interstellar from 2014? That movie was all about space stuff like wormholes, alien planets, and black holes. But the wildest moment was when our hero, Cooper, took a dive straight into a black hole named Gargantua. Yeah, things got crazy. So when Cooper falls into a black hole, at first, it's all darkness. But soon, weird stuff starts happening. Grainy particles hitting his spaceship, sparks flying, and, oh yeah, the whole thing catches on fire. Eventually, Cooper ejects from his ship, and before you know it, wham, he's in some trippy, five-dimensional space where he can communicate with his past self. Time travel via gravity. So you might be thinking, is this for real? Can black holes actually do this? Let's break it down. What is a black hole, anyway? Black holes have been lurking around in space since, well, forever. But we only figured out they existed about 100 years ago. A black hole is like the ultimate cosmic vacuum with gravity so strong that even light can't escape. They're the universe's big, scary, invisible monsters. To understand black holes, we gotta start with Einstein. You've probably heard of his theory of relativity. It's the one that messes with time, especially when you're speeding around in a spaceship or near something with a huge gravitational pull, like, you guessed it, a black hole. In fact, if you ever went near one, time would slow down for you, but back on Earth, time would just keep ticking away like normal. This is what they showed in Interstellar. When Cooper visits the water planet and 1 hour there equals 7 years on Earth, that's gravity messing with time. How do black holes form? Black holes are born from stars. Stars are like nuclear power plants burning hydrogen and helium, pushing out heat and light. But once they burn through their fuel, things go south. Gravity takes over, and the star collapses. If it's a huge star, it could end up as a supernova and then shrink down to become a black hole. So when a star dies and goes black hole mode, it's like all that mass gets squished into a tiny, super dense ball. How tiny? Well, if the sun became a black hole, it'd be only 50 kilometers across, about the size of a small city. And do not forget that before sun became a black hole, 1.3 million Earths would have fit inside it. Just imagine. Types of black holes. There are different kinds of black holes. Number 1, stellar black holes. These black holes form when a massive star exhausts its nuclear fuel and collapses under its own gravity. This happens during the star's final stages, often following a supernova explosion. The core of the star shrinks dramatically, condensing its mass into a very small, dense region. Despite their small size, which is a few tens of kilometers in diameter, stellar black holes are incredibly dense. A stellar black hole can have a mass ranging from about 3 to 10 times that of the Sun, packed into an area as small as a city. To give you an idea, imagine compressing the entire mass of the Sun into a sphere with a diameter of about 30 kilometers. These are the most common type of black holes and can be found scattered throughout galaxies. In fact, there are likely millions of stellar black holes in our own Milky Way galaxy, though they are difficult to detect unless they are actively interacting with nearby objects like stars. 2 supermassive black holes. Supermassive black holes are much larger and more mysterious than stellar black holes. They are thought to form either from the merging of smaller black holes, the direct collapse of massive gas clouds, or through the gradual accumulation of matter over billions of years. Scientists are still unsure exactly how these colossal black holes form. As their name suggests, these black holes are supermassive, with masses ranging from millions to billions of times that of the Sun despite their mass. Supermassive black holes are much larger in diameter, often taking up a region that could be as large as our solar system. These gigantic black holes sit at the centers of galaxies. For example, at the heart of our Milky Way galaxy lies a supermassive black hole called Sagittarius A, which has a mass equivalent to about 4 million suns. Nearly every large galaxy is believed to have a supermassive black hole at its center, shaping the galaxy's structure and evolution. Number 3, intermediate black holes. Intermediate black holes are the middle child of black holes. They have masses between stellar and supermassive black holes, generally ranging from 100 to 100,000 times the mass of the Sun. Unlike stellar and supermassive black holes, the existence of intermediate black holes is still somewhat of a mystery. They are thought to form when smaller black holes merge or from the collapse of large star clusters. They're much larger than stellar black holes, but not quite as enormous as supermassive ones. Their size could be several hundred kilometers across depending on their mass. Intermediate black holes are elusive. and finding solid evidence for them has been challenging. They may exist in the cores of dense star clusters or in the outskirts of galaxies. Scientists have observed a few possible candidates, like HLX-1, located in a galaxy about 290 million light-years from Earth. These black holes are considered quite rare. One theory is that intermediate black holes are transient. They either grow into supermassive black holes over time, or they may be difficult to detect because they lack the large accretion disks that make stellar and supermassive black holes more noticeable. Number 4. Primordial black holes. Primordial black holes are the most speculative type, believed to have formed just after the Big Bang. Unlike stellar black holes, which form from stars, primordial black holes could have been created from the intense pressure and density fluctuations in the early universe. These would have been tiny black holes, formed before stars and galaxies even existed. These are theorized to be as small as an atom, but despite their small size, they could have masses equivalent to a mountain or larger. Some may even be much more massive, rivaling the mass of small planets. Their sizes could vary from microscopic to planetary scale. The hunt for primordial black holes is ongoing. Some scientists think they might make up a portion of dark matter, an invisible form of matter that makes up most of the universe's mass. However, no primordial black holes have been directly observed yet, and they remain largely hypothetical. If these black holes exist, the smallest of them may be evaporating through a process called Hawking radiation, predicted by physicist Stephen Hawking. This radiation slowly reduces the mass of black holes over time, causing them to shrink and eventually vanish. Larger primordial black holes could still exist, but smaller ones may have already evaporated. So, what happens if you fall into one? If you ever find yourself skydiving into a black hole, here's what to expect. First, you'll see the accretion disk, which is the swirling hot gas and debris orbiting the black hole. It glows super brightly, even though the black hole itself is, well, black. As you get closer, things get weirder. You'll notice the light bending around the black hole. Gravity warps space so much that light curves, creating a ring-like effect. You'll also see something called the photosphere, a region where light is trapped orbiting the black hole. Crazy, right? Then comes the event horizon, the point of no return. Once you pass this line, even light can't escape. You're officially toast. Well, actually, you'll probably get stretched out like spaghetti thanks to something called spaghettification. Gravitational forces are so intense that they pull you apart atom by atom. But hey, who knows? Maybe there's some funky 5-dimensional world inside, like in Interstellar. Sadly, that part is pure imagination because truth is, nobody knows what happens beyond the event horizon. Not even Einstein could figure that out. Why aren't black holes just eating everything? A lot of people think black holes are out there gobbling up planets and stars, but that's not exactly true. Sure, they have a crazy strong gravitational pull, but as long as you keep your distance, you're safe. Just like planets orbit the sun, stars and other cosmic stuff orbit black holes at a safe distance. So, no worries, black holes aren't going to suck up the entire universe. The bottom line, black holes are mind-blowing. They mess with time, swallow light, and crush stars into tiny specks. But as long as you maintain some social distancing from them, you'll be just fine. And who knows? Maybe someday we'll figure out what really happens inside. Until then, stay curious and keep looking up. Thanks for watching, and do not forget to like and subscribe.